Well, good day, everybody, and welcome back. And we are learning about gases, right? And last time we talked about the kinetic theory for gases, and this time we want to learn a little more. And let's start with this question here. Consider 5 moles of hydrogen gas in a rigid container. Okay, what does rigid mean? Okay, that means constant volume. Good. What happens to the pressure when the temperature of the gases increase? Pressure. Hey, do you guys know what pressure is? I'm not sure that I know what pressure is. Let's see if we can learn something from our concept map here. So here we have gases, right? Here are gases. And we talked about a definition. And we talked about the kinetic theory and the assumptions in the kinetic theory. So let us come down here and talk about holy cow, how much did I write last time? Can we ever get to the end here? Yes, no, not yet. There we go. Good. Whoo! Let's talk about pressure. Man, there was a lot of pressure on me just finding the end of all that mess I created last time, wasn't there? So what is pressure? Let's start off with a definition. And I think the broadest definition for pressure is force per unit area, okay? And so that is a general definition of pressure, and that applies to not just gases, but anytime we refer to pressure. Now, there's a special situation with gases. Gas pressure, not gaz pressure, but gas pressure. Well, gas pressure is still force per area, but what's the cause of gas pressure? The cause of gas pressure is the collision of gas particles against against the walls of my container. And what's a container? Well, a container is anything that's holding gas. So let's consider my bicycle. Okay, here's my bicycle. It's carbon fiber, and I have some tires on it, and it looks something like that. And I get really low when I ride, and I kind of look like that. And there's my head. Don't have a tail though, like that. I don't know. That looks something. There we go. And I've got a helmet that goes like that. And I'm just going so fast, right? And I have 100 pounds per inch of pressure in my tires. Well, what's causing that 100 pounds per inch? Well, if we magnified this tire, we'd find that there are oxygen and nitrogen particles floating around in here. And what are they doing? Well, they're flying in all kinds of directions, right? And because they're in what? Continuous, rapid, random motion. And what they're doing then is they're hitting the side of my tire. And they are creating what? Every time they hit one of those, I feel or I could measure a pressure, right? So these collisions against the wall of my tire make it have 100 pounds pressure. So just remember that the cause of pressure for gases is the collision against the walls of the container. Good. And several things are going to affect that. So let us see one thing that's going to affect that. And to analyze this, we're going to go back to our assumptions in the kinetic theory. So we want to know pressure. Okay. When the temp of the gas is increased. All right. So here I go. Here is my fixed volume container, and I have some gas particles in here, right? And those gas particles are flying around and they're bouncing off the walls of my container, and there's a pressure. Now, something happens to raise the temperature. Temperature doesn't change on its own. In this case, in most cases, heat is added. So we add some heat, and we see that the temperature goes up. Well, what does it mean if my temp goes up? You guys remember that? If we go back and look at our notes, this is wow. Our notes and where are we? Hey, here we go. What is temp? Temp is a measure of what? Temp is a measure of my average kinetic energy. Average kinetic energy is what? Velocity, aha, I know what's happening now. Good. So if my temp goes up, that means what? My velocity of particles has increased. So the velocity of particle goes up, the temp goes up. What does that mean? These guys are moving faster and flying around. If they're flying around and moving faster, what does that mean? That means I'm going to have an increase in the number of collisions against the wall. And if the number of collisions increase, then what? That means my pressure increases. There we go. So what happens when my temperature increases? My pressure increases. Why? Because of all these things. Velocity increases, number of collisions increase, which means my pressure increases. Next, what happens to the pressure when 2 more moles of gas are added? Okay, so here we go. Here's my rigid container. I have some gas in there, and then I'm going to add some more gas. We'll go with a different color here. So I add some more gas. There we go. What happened now? Well, I have more particles. What are they doing? They're all flying around at rapid, random, continuous motion, and they're bouncing off the sides of my container. And when they bounce off the sides of my container, what do I get? I get a measure of pressure, right? If I have more particles, I increase my number of particles, what's going to happen? Well, if I have more particles and they're all flying around, I'm going to get, that will lead to what? An increase in the number of collisions. And if I have an increase in the number of collisions, that means what? My pressure increases. So pressure increases. Why? Because there are more particles. More particles lead to more collisions. More collisions lead to greater pressure. Cool. Next. This one's a little harder. I have 5 moles of hydrogen gas at constant pressure. What does that mean? Constant pressure. That means I have to have the constant number of collisions. Okay, this is going to be tricky. What happens to the volume? Volume, are you telling me volume can change? Sure. Right? Let's say I have something like this, and we'll call it a piston, right? So that means this section right here kind of floats. It can go up or it can go down as necessary. Good. And in here we have our particles, right? I have 5 moles of particles. Now the question is, if the temp of the gas decreases, okay, so I'm going to decrease temp. Well, I can't decrease temp. What can I do? I can decrease heat, remove heat. That'll lead to my temp going down. And if my temp decreases, what happened to the velocity of my particles? Well, for my temp to be lower, that means my velocity of my particles was lower, right? And if my velocity was lower, that means they are traveling what? They're covering less distance. You know, the distance traveled, distance traveled per time is less. And if there's less distance and my volume's the same, then I would have fewer collisions. Okay. But we want to keep my collisions constant. So how do I keep from having fewer collisions if my distance traveled per time has decreased? Well, that means I have to do what? I have to change my volume so that there's less distance necessary for a collision. So what am I going to do? I have to decrease volume. So I would bring my piston down here. That means my particles have to travel less before they have a collision. Since the temperature is down lower, the velocity is down, and so they are traveling at a lower rate, and there will be the same number of collisions since I lowered the volume. That's a little bit trickier, right? What happens to volume? It decreases if the temp of the gas decreases, right? Because my particles are slower and I have to maintain constant pressure. Next, 5 moles of hydrogen gas at a constant pressure. Man, this constant pressure stuff is tough, isn't it? What happens to the temp if the volume is increased? Okay, I think we can do this. Here's our piston, right? And let's say this is our initial condition, right? And it's at a certain temp. And so, T1, and I have a certain pressure caused by the collision, P1, right? And then what happens? What happens, we're going to increase our volume. So we're going to get rid of this guy. Oops, I have magic here. Ooh, it's gone. Yay. Good. And where is it now? It's now up here, right? But now my particles have to travel farther for a collision to occur sometimes. So if they have to travel farther, that means there's going to be fewer collisions if they're going at the same velocity. But we want to have constant pressure, so they have to travel farther, and so my volume goes up, right? That means there is a greater distance between collisions with wall, right? So what must happen for me to have the same number of collisions? So to keep the same number of collisions, my particles must do what? Particles must travel faster. Must, it looks like German. Muss, must have a higher velocity. And if they have a higher velocity, that means that will be reflected in a higher temp. So what happens to the temp? It must go up if the volume is increased, and I want to keep constant pressure. Okay, I think you guys are handling this right. Good, we'll find out. Here we go. Consider 7 moles of carbon dioxide gas in a 2-liter container at 298 Kelvin. How could you increase the pressure of the gas in the container? Describe 3 ways. All right, put me on pause. You guys come up with answers. Bring me back when you're ready. Well, did you have problems or did you find this to be easy? I think you guys probably did this pretty easily. 3 ways. Okay, number 1, what do I want to do? I want to increase the pressure of the gas. Okay, I know one thing I can do. I've got a container, right? And it's got 7 moles of carbon dioxide. How can I increase the number of collisions? Well, I could do what? I could add a couple more moles of gas, in this case carbon dioxide. So I'm going to increase the number of moles of gas. That's going to lead to what? An increase in the number of collisions against the side of my wall, and an increase in the number of collisions will increase pressure. There we go. Number 1. Yahoo. Number 2, how about I start off here with my container and I have what? 1, 2, 3, 4, 5, 6, 7. And I need to increase the number of collisions, right? Well, what could I do? Well, if I added heat, then I would increase the velocity of my particles. If I have a higher velocity and the distance traveled is the same, then I'm going to have what? An increase in the number of collisions. If I have an increase in the number of collisions, then I'm going to have an increase in pressure. Good. And what about the third possibility? Let's go with what color here? Ooh, that color. 3. That looks like the same color I did before. Let's go with that color. 3. There we go. Lime green. Oh, lime green. What can we do? I start off with a container. It's got 7, 2, 3, 4, 5, 6, 7 molecules or moles of carbon dioxide. Now, how can I increase the number of collisions, right? I want to increase pressure. That means I have to increase the number of collisions. I've already added stuff. I've already increased temperature before, so I can't use those. What can I do? Well, I could decrease my volume. If I decrease my volume, that means there is less distance between collisions. And if I'm going at the same speed, so that would mean at same velocity, then what? If I'm at the same velocity and I have to cover less distance between a collision, that means the number of collisions increases. Good, and if the number of collisions increase, then pressure increases. Woohoo! Yay. Let's see what time it is. Oh, I think that's good enough. All right, folks. We'll call it quits on pressure today. Next time, uh, uh, you know what? I think we can get this. I think we can knock this out. Yeah. Yeah. I'll tell you what. We'll quit right now. Next time we'll go into pressure conversions. Ciao.